Hi, it's Mr. T here. This video is about how titrations work. We're going to go into actually the mechanics of how is it that we see a change of color at the end of a titration. In this example, we're going to use an acid-base titration. So here's a setup on the right, ready for us to carry out a titration. We have at the bottom some hydrochloric acid that we've put into a conical flask. We've put an aliquot of that in, or a specific volume from a pipette. We've also added 5 drops of phenolphthalein indicator. Now, phenolphthalein indicator is an indicator that will be colorless when it sits in an acid or neutral solution, and if it's in a basic solution, that is, if there's an excess of hydroxide ions, it's going to be a pink color, a bright pink color. In the burette, we've got some sodium hydroxide, a base, and you can see here from the setup, what we're going to do is we're going to add the sodium hydroxide to neutralize the hydrochloric acid. And of course, when that happens, it turns into neutral sodium chloride and water. So let's look at the actual animation of what. Okay, so here's the titration setup. I've already carried out 2 titrations. I've done a rough sample and I've done my first accurate sample. Now, remember here when I subtracted my initial value read off the burette from the final value, I got 15.5 at the start. Now remember, the rough one always goes a bit further than we would have wanted to stop, because we didn't actually recognize the color change till after it's happened. When we do the second one, we're anticipating where it's going to change color, so we get a lot more accurate answer, because near the end where we think it's going to change, we just add a drop at a time. So I'm about to carry out this titration to see how do titrations work. If we look at the conical flask at the bottom, we can see the concentration of the hydrochloric acid is represented by the density of the particles in the volume here. And the same with the concentration of the sodium hydroxide and the burette at the top. Now, when I add any of this sodium hydroxide, a sodium hydroxide particle react with the hydrochloric acid particle, neutralize it, and we won't see it anymore. So let's take a reading just before we start. We're starting here at 35.2, so I write this. This is my second titration here, so I'm going to write this as my initial reading, and I'm going to add some solution. Watch this carefully. What happens to the amount of solution, or what happens to the amount of particles that leave the burette? What happens to the amount of particles that are then of hydrochloric acid that are left in the conical flask? Let's add them. And there we go. We added some of the solution from the burette, and now we've stopped. Now we actually don't see the particles, but this is a depiction of how it would be. So notice that we have, because we added a certain number of the sodium hydroxide particles, they've reacted with the hydrochloric acid particles, and quite a few of them have disappeared now. And we have more liquid in the solution, and we have less hydrochloric acid particles. So we now have a lower concentration of hydrochloric acid particles. Now I want to stop exactly when I have reacted the exact number of sodium hydroxide particles with the hydrochloric acid particles. They actually react in a 1-to-1 ratio for this reaction of hydrochloric acid and sodium hydroxide. So I'm going to add some more. Okay, let's go. I know that I'm going to add about 13.2 milliliters, right? And if I add that onto here, I know that if I go to about 48, I would have added 12.8. So I won't be at the end point yet, but I'll be very close. So let's add enough solution, so we're about 48. There we go. I've added the solution. It's about 48 mils. I've neutralized just about all of the hydrochloric acid. Now I know that because I've carried out the titration before, and I'm showing that because I'm showing there's just one acid particle left. Now at this part of the titration, of course, we're only going to add a drop at a time, because as soon as I add a drop, I'm going to add just a small amount of sodium hydroxide particles that will neutralize the last of the acid particle, and then add a very small excess of sodium hydroxide particles in the bottom. You can see that represented at the bottom. Now, of course, as soon as we get this excess of sodium hydroxide, the solution becomes basic, and the phenolphthalein, when it's in a basic or hydroxide solution, will turn pink. Now, as soon as it turns pink, it means all of the acid has been neutralized, and therefore we've got a little bit of base now. Now we stop it as close, right on that changing point, and that's how we become accurate at these titrations, is we stop at that point. I now record the result here, 48.3 milliliters it is, and I can work out the titer if I want, which is 13.1. And this video has shown you how on the particle level a titration works, and why it is that the color changes, and why it's important that we use techniques to stop right on the color change if we can. I hope the video has been helpful. Look out for the other videos on titrations if you need help.